Okay. Good afternoon, everybody. Thanks so much for taking some time to join us. Looks like we have a really good turnout this afternoon, which is really awesome to see. Thanks so much again for taking the time. If someone can actually just click the raise hand button if you can hear me okay, that would be, thank you, James. And great. So, Michelle, can you hear me okay?
Yes, I can hear you fine.
Excellent, excellent. So, again, good afternoon, everyone. Thanks so much for joining the webinar. Today we're going to be talking a little bit about model-based definition. My name is Dan Petito. I'm an inside account manager here with Design Point Solutions. I'm also joined by Michelle Cloutier, who is a technical manager with DF SolidWorks. And basically, Michelle is going to discuss with us and tell us a little bit more about model-based definition this afternoon. So I'm going to hand the controls over to Michelle. And thank you again, everyone, for joining. We do ask if you could hold some of your questions until the end. If we do have some time, we'd very much like to get those answered. So again, thanks for joining us, and I'm going to hand it over to Michelle.
All right. Well, thank you. And can you please just confirm that you can see my screen, you can hear me fine? Dan, can you just confirm you're seeing my screen and you can hear me, hear the audio?
I am.
Okay.
I am. Yep. Sorry.
All right. No problem.
A couple hand raises to confirm too. Sorry, Michelle.
No problem.
Thank you.
All right. So today we're going to talk about SolidWorks MBD, and just to do a bit of introduction about what is SolidWorks MBD, what does it do. I thought I'd start with something very simple, kind of illustrate what is MBD. So let's say you have this part, you want to manufacture this part, so that's the end product you're seeing on the screen. Really what you want to do, where you start, is really with a model, right? So you, right now, go into SolidWorks and model your part you want to have manufactured. Now, this part is going to be manufactured in different ways. Well, not in different ways, but there's different steps it needs to be manufactured to. And how do we illustrate what's the precision, how to manufacture this part? Well, you use drawings, right? So you create a 3D model, and then you create a drawing to illustrate how you need this to be manufactured, the specs, the tolerances, the geometric information, and you put that on a 2D drawing. Now, the idea behind model-based definition is really not very difficult. It's simply to take all of that annotation, but leave the annotation on the 3D model rather than creating a separate file, creating a separate drawing, two things, the parts and the drawing, living side by side. Instead, you take all of that information and leave that information on the 3D model. And basically what you put on the 3D model, it's a typical acronym we'll hear a lot, is PMI, Product Manufacturing Information. Basically, all the dimensions, the geometric tolerances, everything you need for this part to be manufactured. So in essence, that's what model-based definition is. Now, why is model-based definition important? Well, it originates from actually the military. The Office of U.S. Secretary of Defense did a lot of studies over the years, and they found out that a third of their engineering dollars are spent in 2D drawings, yet 60% of them don't match the 3D models. So think of this. You're spending a third of the money making drawings, but yet almost 2/3 of the drawings don't even match the 3D model. So it begs the question, why should we make drawings in the first place? Well, we need drawings to convey information, right, to convey the manufacturing information. So while looking at this, they came into the understanding that we have to reduce the number of drawings simply because it costs too much money. I'm not saying 2D drawings will completely disappear, it probably won't, but reducing the number of drawings is definitely something that more and more companies are looking for. Now, for this presentation, I'm actually going to work on a model from a customer called Watershot, and they do cameras for Hollywood, basically, but to film underwater. And when we look at this camera, there's actually a little gear mechanism that sits inside that camera, and you can probably assume that these gears are there's a really precise fit and fit form function of these gears. Everything has to be really compact. Precision is key to get good good film going. So I'm going to work on this model, and I'm going to show you how you can actually capture all the manufacturing information, but on the 3D model. And while I'm doing this, I'm going basically to walk through 3 different steps. First, we talked about PMI being the product manufacturing information. So I'm going to start by adding 3D PMI and organizing this PMI information on my model. We're going to kind of pause at that and then go to adding a bit more information just to make the model a bit more complete with more information, but also talk about configuration. What happens when you have different configurations of the same part and you want to annotate both of these configurations? And lastly, we're going to talk about how we can share that data with people inside the company, people outside the company, and we're going to talk about this a little bit after the fact. So let's start with adding and organizing my 3D PMI, again, PMI for product manufacturing information. So I'm simply going to jump into SolidWorks now. And here you can see actually my little assembly. I showed you an image a little bit before. If I zoom in, you'll notice that there's a lot going on here, very precise mechanism. So obviously detailing this part or this assembly correctly is critical for good function. So let's go ahead and open this part. And typically, one of the first things we find in a drawing are simply annotation, general annotation for manufacturing. So here I'm going to simply go to my design library where I actually have a set of notes here. I'm going to simply drag and drop this into my model here. Let's just reposition this quick. Now I'm adding this directly on my 3D model. So you see here, this is still my 3D model. I just added notes inside my 3D model environment. One thing I want to do as well is that these notes, even though they're in the 3D model environment, I can still tie them to properties, file properties, or any type of properties we have inside SolidWorks, for example, material, so I don't have to fill in this information automatically. So that's fairly easy to do. But we still haven't have any dimension, anything on the model to manufacture. So that's what we're going to do next. Using the DIM Expert tools found inside SolidWorks, we can start by defining my datums. So if you're in manufacturing, you know what datums are, basically my references. So I'm going to select the bottom plate, this cylindrical feature here, which is where a bearing would sit. And my third datum is going to be this hole here, but I have to be careful. There's actually a shaft going in here. So this would be a continuous feature. And I'm going to select both of these together. And next, I'm going to go ahead and set, let me just do that again here. Just reset my datum and as such. And lastly, I'm going to simply select the machining features I want to detail or dimension. I'm going to select the bottom holes. You might have noticed that SolidWorks is intelligent enough to understand that this is actually a pattern of the same hole, so that's why both are highlighted. I select the back hole here, click OK, and basically SolidWorks starts adding some of the annotations on my 3D model. Now, one thing I like to do here is very quickly go to my display and show instead the annotation base tree, where if you look side here in the left, you'll see my datums on top, and then you'll see the dimensions I'm actually starting to add to my 3D model as I'm doing this. So let's go back to my model. And one thing here that is also very interesting is that these dimensions are kind of smart. Actually, they are pretty smart. When you select them, it will actually highlight the geometry on the screen to where this dimension is attached to. So finding the information becomes very easy. Everything is kind of hyperlinked. So if I select a annotation, the holes attached to that annotation highlight. But I need to organize this a bit more. So we're going to go to the top view. And here I got one annotation for the hole. And what I want to do with this is call out the position or the basic dimension of this hole. So simply by doing a right click, I can call in the basic dimensions to place these holes. Now if I just slightly rotate this model, you'll see that some of the dimensions here, the 3 and another one, the 4 down the bottom, were not placed on the right view. So I can simply move them to the top view. And basically what I'm doing is, think of this as creating views, but in the 3D model instead of a drawing. So here I basically have a top view where I have all my dimensions positioned in my top view. And when it's time to capture this, I can go ahead and capture this top view. I'm going to simply filter out what I don't need and click OK. And now you see here down the bottom, I'm starting to build some sort of storyline. So the first view I did with notes was here. I'm starting to build a top view. And as we're going to be progressing today, I'm actually going to be building more and more of these views. And if I want to switch back to one or the other, it's simply a double click away. So here I'm back to my overview with notes. Here I'm back to the top view. Now let's go ahead and go to the front annotation view. And we're going to add some more information here as well. So we got a couple dimensions that are called out right now. If I want to change some of the arrow styles, so maybe I like to see the arrows inside instead of outside, kind of makes it a little bit easier to read. I can easily do that. I can also add my dimensions automatically as well, just like I've done before. So this is the height of my hole. And now if I'm happy with this view, again, I can simply capture this as being my front view. So here I got the top view, double click here, there I got my front view. Now one thing on this front view, I'd like to detail the whole pattern, right? When I select this face here, you can see I have a flanged face, so I get a flange connection here, I get a whole pattern, and I want to dimension this whole pattern. So how do we do that? Actually, it's, again, fairly simple to do. We have tools that do that, that help you do that automatically. So for example, I'm simply going to select this datum. I only need one because I only need to dimension the pattern of holes. I select one of the holes. Again, notice how SolidWorks is intelligent to understand that this is actually a pattern, not a single hole, so it captured all 6 of them. And when I click OK, all the annotations are added to my model. So I get all the annotations for the hole pattern. But as I'm starting to do this, I realize that this view is starting to get a little bit busy. Yeah, right? I got a lot of information. Now, to detail something like this in a drawing, typically you would create detailed views, section views, additional views, just to isolate what you really want to show. And we can do the exact same thing here. So I'm going to start by inserting a new annotation view. And I'm going to start from the front. And on this new annotation view, I'm going to select the dimensions that I want to move to this new view. So all the dimensions that are related to my hole pattern, I'm going to select. I got 3 of them. I click OK. And now I'm going to capture and call this hole pattern. So I'm simply calling out this new view, And in this view, I'm simply going to isolate the dimensions related to my hole pattern. So by doing this, again, I can go to my front view where I got my dimensions only for the bearing mounting holes. But if I double-click my hole pattern, I got the dimensions that only show or highlight what I need to have available just for manufacturing the hole pattern. So again, I can recapture this just to update the zoom factor. And again, I can simply cycle through each of these views as I want to. So really, the idea behind SolidWorks MBD is to be able to really quickly annotate and also organize your PMI information. Really, it's not much different than making a drawing, except that you do that in the 3D model. You create your views, you organize your dimensions and tolerances in those views, but you do that in the 3D model instead of creating a new file, having to manage another file, which is the drawing. You just keep everything into your 3D model. So now that we've quickly started annotating this model, started organizing, we need to add a bit more information. So I'm going to continue on adding a bit more product manufacturing information to this model. But I also want to touch on configurations. What happens when you have something a little smaller, a little longer, a little thicker, whatever. How do you tackle this problem using SolidWorks MBD? So let's get back to it. So back to my model. Now I want to detail my right view. So if I go to the right, here you'll see that I don't have anything captured so far. I'm simply going to capture a right view, and I'm going to start adding some annotations to this. So first of all, I can simply select a face and start a dimension. But here I have to be careful because this face, there's a little face here that actually part of the same machining feature, right? When we do GD&T, we talk more about machining feature versus modeling features. But I want to make sure that these two faces actually are one of the same when it comes down to GD&T, to tolerancing and dimensioning. So I'm going to capture this. Now that it's done, I can simply go ahead on the back here, draw my dimension. Just like any other dimensions inside SolidWorks, you have control over precision, tolerances. Here I might want to change that to be a limit type of tolerance and precision. And we'll touch more about the default tolerances and precision in a bit. But let's just go continue and add some more information. So let's say I want to dimension this face here. Let's just zoom out a little bit, put it over here. Maybe I want to dimension the height of these two faces, and lastly, maybe just the thickness of that bottom plate. Now, as I'm doing this, all of these dimensions are being added to my right view here, as you can see. But in some cases, this is going well, but in some cases, like the flat face here, where I have rounds on top and the bottom, I might want to annotate directly to what would have been a sharp edge before I had a fillet there. So we can easily do that with SolidWorks MBD just by using intersection MD. So for example, selecting these two faces, you can see here highlighted on the screen there's actually the axis or the intersection of these two faces being selected. And I can do the same on the top here, just by selecting these two faces. And now SolidWorks will add a dimension to what would have been a sharp edge if it wasn't for these fillets here. Now I can reorient, but when I look at this dimension, this is currently the normal dimension. And enough in case you'll simply want to realign this, we can easily do that to be a horizontal or vertical dimension. Let's drop it where we need to. And when we're happy with this view, we can simply recapture and update this view. So again, I'm basically building a storyboard of dimensions down the bottom here. Now let's move to the opposite side, which is the left side. And over here I got a dimension, and so far you've seen me adding new annotations and new dimensions, but we can also reuse what is already existing. Speaking of features and sketch dimensions. So my features and sketch dimensions are still in my model, and I can reuse them if I want to. First of all, let's see how we do that. I'm simply going to capture my left view, and I'm going to call out everything that's unassigned, meaning all the dimensions here actually used for this model are shown on the screen. It makes a little clutter, but what I can do is simply Control select just the dimensions I actually need to show in this view. And then I'm going to move them to the left annotation view. So by doing that, now you can see that my left annotation view here has only the information captured in my model. And these are annotations that are actually, that came from the features or the sketch dimensions I can simply reuse directly into this view. Now I'm not done yet because I also want to detail, if I simply turn this a little bit, I want to detail the holes on the backplate here. The backplate meaning the face I'm selecting here. But if I look at the left view, I'm being obstructed by the front plate. So I need to detail this in a way that everyone can understand. In a drawing, what you would do is probably just do a section view, right? You would call out a section view and go detail on the second face and hide part of the model. Well, we're going to do the exact same thing here. So first of all, let's create a annotation view, and I'm going to call it from the same orientation I'm working on right now. And I'm going to simply start a section view, set the right orientation. This is better. So I got my section view going on. Let's just reorient our model so we can see it from here. Now I don't need some of this information, so let's just go ahead and hide what I don't need to show. And before I'm going to start detailing this hole here, let's take a quick second here to talk about how do we control the tolerances and all of that. So basically, all of that information is captured in your document properties, pretty much the same way you would for your drawings. What do you want your arrowheads to look like, and what's the font you want to use. But if you go down here to Dim Expert, you'll actually find the information relevant to dimensioning and tolerancing this model. So here I'm simply going to add to create my basic dimensions automatically. You saw me do this manually earlier when I right-click and added basic dim or basic dimension. This I'm going to simply set it so it does it automatically. And now if I want to dimension this hole, simply select the hole. I'm going to drop a dimension. Notice that it understood there were two of them, so that's why you see the 2x called out already on this dimension. But I need a bit more information, so I'm going to add a GD&T control frame. So I'm going to say position, diameter, maximum material condition. I'm going to say towards my datum, A, B, and C. Now one thing, I'm going to actually, on purpose, make a mistake. I'm going to put D as my tertiary datum. Notice how Dim Expert, the tool we're using to tolerance or dimension, is actually smart. It does over 100 checks. GD&T rule checks, and here it says to me that hey, your datum D doesn't exist. So that's why. So maybe it's simply a typo, but it's nice to know that we actually do some rule checking in the background to help you with your design. So if I change that to C, you see there's no warning. I might want to tweak that down a little bit, so we'll say 0.1. And I'll say OK. And as I'm adding my control frame here, you see that all my dimension is already added to my view. So the only thing I need to do now is maybe just reorient my model. Maybe this one I'm simply going to slide it over here. I'm happy with this view, so I'm simply going to capture this, and I'm going to say this is my section view. And click OK to that. So very quickly, I got a left view that calls the whole information on the front plate of this part. And then I got a second view that calls the whole information on the back plate of this part. Again, very similar to what you would create right now inside a typical 2D drawing, except that I can rotate this model. This is 3D. If I select some entities on the screen, it actually highlights for me which entities they are on the model. Also, I can also take a look at all the annotation at the same time. When I do that, it does become a little hard to understand. So we've came up with a unique tool that's actually patent pending right now, that we simply highlight or fade in and out annotation that are pertinent to the orientation I'm looking at. So as I'm moving this model very slowly here, you see some dimensions fading in, some others fading out, just to show what is really relevant for me to see in that particular orientation. And same would go if I, rotate to see it from the top. So this is a very unique tool we've came up with. It's patent pending. And this is just a great way to show and see how we control the annotation and the visibility of those annotations. Now, I talked earlier about configurations. And this is a good segue into that. This part actually comes in multiple configurations. And I got another configuration here called version 2. And if I switch configuration, you'll notice this part is different, right? The flange are thinner. The shape of the flange are a little bit thinner as well. And I want to, in the same model, annotate this. Now, in a drawing, what you would typically do is create a second drawing. It's one part with two configs, but then you already have two drawings to have everything shown. Here, what we can do inside the same model is simply copy all the annotation I did on one config to the other config. And very quickly here, I got my annotation. The one that are not relevant, I can simply delete, maybe because that manufacturing or that hole was removed. And I'm able to capture both of these annotations on both of these configurations within the same model. So here I got version 2. If I double click here, I got version 1. So all of the manufacturing information for both of these configurations are now captured in the same part file that I've been working on from the beginning. So really, another key thing here is, we want you to save time by, doing less of, making less drawings and spending less time doing drawings. Hopefully, you see the benefits here that, we can do all of this quicker directly on the 3D model versus having to create drawings. Now, the last thing, and that's going to be a key issue, is great. I've got all this information inside SolidWorks, but the guy I deal with down the road doesn't have SolidWorks. He's a machine shop, right? So he needs to be able to see what the heck's going on, what he needs to manufacture. How do I share all of that information? Well, there's a couple ways to do that, and I'm simply going to walk you both options, basically e-drawings and PDF. I think everyone knows PDF, so we're going to talk about this, of course. So let's go back to SolidWorks. We're at a time where I need to share this with someone else, someone inside my company, someone outside my company. If you've been using SolidWorks for a little while, you're probably familiar with e-drawings. And yes, you can simply publish this directly to an e-drawing file. So all the information captured here will actually be, I was going to say translated, but it's not really the good terminology. It's basically just captured in my e-drawing. So here you can see my e-drawing file. And if I go into my 3D views, you see all my 3D views I've created inside SolidWorks are all here. So I can cycle through each of these views to see what I really need to see. Now, e-drawings is a great tool. I love e-drawings a lot. But a lot of people will probably rely on PDF. A lot of people know PDF, have PDF Reader installed. Everyone is familiar with it. So we've included with SolidWorks MBD the ability to publish a PDF, but not only that, the ability to create your own templates. So what will the published result look like? So with SolidWorks, you have a PDF template editor, which is showing on the screen right now. Just to give you a bit of an idea here of the default, some of the default templates that we ship with the software are shown here. You can create your own from scratch, or you can copy and modify these. It's really up to you. But what's really interesting is that it allows you to capture some of the information or properties inside your SolidWorks file and push those automatically to the PDF file. So let's do that quick. So I got my part. I'm ready to publish this to a PDF or to send it to someone that has, I want to share this. I'm simply going to say, I want to publish this 3D PDF. What are my file? I'm going to simply say simple part, format, select the views I want to publish out to. And here, before I actually publish out, I can actually map some entities, some options directly here. So for example, I can say, well, hey, my part number, I want this mapped directly to my PDF file. And same with the material. So I don't need to type all that information. It can actually be pushed out to the PDF automatically. So when I'm happy with that, I can simply publish it out. I'll simply go to one I've created earlier. And this is the result. This is what you get. It's a PDF. Notice that I'm opening this with Adobe Reader, the free reader that everyone gets pretty much. What I can do is that you'll realize very quickly that this is actually a 3D model floating basically inside my PDF document. Again, anyone that has PDF Reader can see this model in 3D, navigate this model. And check this out. If I select a dimension, the feature, the faces associated with this dimension also highlight. So it becomes a tool that's very easy to understand and very easy to get to understand this model. I can even do with my 3D PDF, I can even do things like measure right on my 3D PDF if I want to. So I got even measuring tools right inside my PDF. So I can cycle through each of these views. As you can see here, I got my views that I've created inside SolidWorks where I can simply cycle through them and look at all of these views. I got my notes. I got my information about my model that was grabbed. And I can also add some more information. So, if I send this to a fabricator, he might want to ask how big is the order. So maybe to get some sort of discount on quantity. So I can actually add some annotation in my PDF and save that annotation if I want to and send the PDF back. So the PDF is a great way to share this information. Now, so far I've only talked about this single part, but what about assemblies? Well, pretty much like parts, you can create those views within the assembly. And here I got actually a couple of views showing sections. I got this view here that also have some dimensions to it. So if I select dimension, pretty much like I've shown before, you see the face highlight where these dimensions are attached to. But I can also add some more information. So for example, I want to dimension the front face of this shaft to the axis of this gear mount or gear shaft. So I can easily do that just by adding a dimension just like this. But also, what we like to see a lot in assemblies, and when you put a lot in assembly drawings, are exploded views. Well, we can do that again here. Basically, inside SolidWorks, exploded views are basically configurations. So here I'm going to simply call out my exploded view, notice I can also play with transparency and color if I want to, just to highlight some of the functionality. So here I got my normal view. Here I got my exploded view. If I want to publish and share this information, again, I would publish it using a template. Now I'm going to select a simple assembly template because I'm going to have actually bill of material called into this template. I can also take the time to add some more information before publishing to the 3D PDF. So I'll just put in my name, and I can simply click OK. I'm just going to bring up something I've created earlier, and again, this is my result. You see down the bottom here, I got my different views. I can cycle through these views with my dimensions I've added. I got my exploded view, but you'll probably notice this on the side here. I also have something else. I have my bill of material. So even though I haven't done a drawing, I can still pull bill of material information in my 3D PDF. And look at this. This bill of material is actually intelligent. It's linked to the model. As I select an item in the bill of material, I see it highlight on the screen, and vice versa. If I select a shaft here, it actually highlights in the bill of material. I see there's two. If I select it here, now both of these shafts highlight on my 3D PDF. So again, I'm reading this file with simply Adobe Reader. Pretty much everyone has Adobe Reader installed on their computers already. So hopefully you can see how easy it is to communicate the designs with pretty much anyone just using PDF. According to Adobe, fun fact here, 97% of computers on the planet connected to internet have Adobe Reader installed. So you can imagine that 97% of your customers or people you deal with will be able to open this file and do whatever I've done just here and now using the free reader. So throughout this presentation, I wanted to show how you could quickly annotate and organize your PMI, product manufacturing information, how much time you get to save by not having to do drawings, not having to manage extra files. It's all in the SolidWorks parts or assembly, and how you can communicate that design pretty much with anyone using standard PDF. So, just on the finishing comments here, more and more companies are looking into model-based definition. There's a lot of discussions, and all of these companies are either looking into it, have already started implementing some MBD initiatives, but it's a hot topic. You're going to hear more and more in the future about model-based definition. And I think this sums it up the best from one of our customers, GE Oil and Gas. With SolidWorks MBD, the 3D model itself holds all the dimensional data necessary to make the part. This means less document creation, fewer emails flying around, and fewer files to sustain when the project is complete. So I think that sums it up. I wonder if there is any questions. I don't know. Do we want to open it up? I'll leave Dan to make the call on that.
Yeah, I mean, obviously we did end up going a little over our allotted time, but a lot of you stuck around. So I mean, it seems like you definitely see some value and have some interest in MBD. We certainly appreciate that. And Michelle, how are you on time? Do you have a few minutes? It looks like we have a couple of questions that came through.
Yeah, I can stick around for sure. No problem.
Okay, great. So let's see. I know that Kevin had asked, so how is this of benefit to the CNC machinist? It seems like a 2D drawing would make the machinist's job so much easier than having to pull dimensions off a 3D model and rotate the model around.
Yeah, to the machinist, I mean, the machinist is going to work on the native SolidWorks file or a step file or something else. It's for the machinist, it's not so much, you're basically just not having to create a file for the machinist with the drawing on it. So all the dimensional, typically you would send the SolidWorks file, for example, so you can read it into his CAM software, but you would need to create a drawing with all the dimensional information, the G, D, and T, so that the machinist knows where, what are the tolerances and, how to machine the part. So you're basically saving the time and, the time it takes you to create that drawing. You just put everything on the 3D model and create a PDF, send the PDF out. So it's not so much for the machinist, it's for the guy that needs to give the information to the machinist that you save. That's mostly where you're going to say yes.
Yeah, absolutely, and thank you for your question, Kevin. If we have time, we'll get to your follow-up question. Absolutely. It looks like Daniel, do 3D PDFs published from SolidWorks work in Nitro PDF Reader?
Nitro PDF Reader. So I have not tried Nitro PDF Reader. So this is something I would need to try. I know obviously it works fine in the free Adobe Reader, but I'm not convinced about Nitro. So this is something, actually it's the first time I heard of Nitro PDF Reader, but I will need to do a bit more digging into that.
Okay. Matthew says, please take my money and let me know how much the add-on costs. You got it. Appreciate your question. As far as pricing goes, I don't know if Michelle, if you have information on that. If not, obviously once that information is released, we can certainly disseminate that to the attendees. And once obviously that's something that's announced, I'm not sure if that's something that's made public just yet.
Yeah, I'll send you the information then. I think it's probably better that you disseminate that to your customer directly.
No problem at all. Happy to do that. Thanks for that. Dennis says, is this capability available in all seats of SolidWorks? Must you have professional? Great question.
That is a great question. So basically, some of this functionality you already have if you have SolidWorks, any seat of SolidWorks. When you saw me annotate the model using the kind of magenta colored dimension, this is actually Dim Expert, and that's built into every seat of SolidWorks since 2008, I believe. So it's been there for a long time. So basically, the dimensioning you can start doing with your, today with SolidWorks. What you get with MBD are a couple things. You get the ability to arrange or capture your 3D views. Remember down the bottom I had my little storyboard of views. So this is only in SolidWorks MBD. The publishing and the PDF template editor is only in SolidWorks MBD. And there's a couple more things that's only in SolidWorks MBD. But some of the technology we're leveraging Dim Expert. So if you have SolidWorks today, just fire off Dim Expert, and you'll be able to at least get a good handle, I guess, of how to dimension the model. That's a very, very good start, actually.
Cool. Appreciate that question. Kurt says, does this work with sheet metal flat patterns and VXF files?
It will work with SolidWorks models in general, so it could be sheet metal, it could be weldments, as long as, if it's in a SolidWorks part or assembly, it'll work. It will not work with VXF because it's 2D, so the technology is really focused on 3D. But one thing it can do is that if you have, let's say, a step file or a IGES file that's coming from another CAD, you can actually do pretty much everything I've done today, even though it was not modeled inside SolidWorks, even though it's, in our lingo, a dumb solid. You can also dimension all of that inside SolidWorks as long as you get it into a part or an assembly file.
Awesome. Great question too, Timothy. So is this available now? If not, when?
Now.
Now. Matt
It
is
is.
happy to hear that, I'm sure.
So so SolidWorks MBD was released at the same time that we released Service Pack 2. So we released
Excellent.
Service Pack 2 maybe I'd say a week and a half, maybe 2 weeks ago. So yeah, SolidWorks MBD is available right now.
All right, Timothy is excited at that answer. Ryan asks how revision control is handled, Michelle.
So revision control, everything I do in MBD, I do directly on the part or assembly model. So you have to control revision at that level. So obviously, if you have a PDM system in place, that is the best way to control revision by adding the up-revving if you need to. But that's how you would really control, because all the dimensional information is actually kept inside either the part or the assembly file. So you would need to do the revision control at that level.
Excellent. Excellent. Thanks for that. And it looks like we had a follow-up question or comment. With respect to the first question on how is the value to the machinist. So the machinist is going to charge the design company more money if it takes them more time to program their CNC, considering that they don't have CAM software.
Okay, so considering a company that does not have CAM software.
Correct.
Is that? Yeah. Well, that's a tricky question. Because if a company doesn't have a CAM software, they're doing the program from start, right, manually. So if they're getting a 2D drawing, they're basically creating their program off of the 2D drawing manually. The difference is that instead of doing, getting a printed copy, all the information is in the PDF file. So there wouldn't be much saving because the process is still done manually. So it would pretty be much of the same for the machinist. Again, the benefit might not be at the machinist end. The benefit is more going to be at the engineering end, where you may not have to create that extra set of files just for the machinist.
Exactly. So it seems like if it's certainly dependent on their process, obviously might not be an ideal fit in that instance. But I appreciate the background, Michelle. Thank you.
Yeah, and then I mean just as general comments, if we want to, I'm available to have a discussion. To maybe this is a particular case, or maybe I'm just not understanding the question correctly. But I'm
Sure.
open to a follow-up call with the customer if that proves.
Sure. Sure, absolutely, and I appreciate you being open to that. That's great. And hey, look, guys, obviously we appreciate the amount of questions that you have. Definitely sounds like you see some value in MBD, and obviously Michelle did a great job of demonstrating some of its capabilities and giving us more of a focused walkthrough. So if you do have any questions, obviously outside of the webinar, you can reach out to Design Point directly. Michelle, I appreciate you offering up to have kind of a follow-up conversation in instances where it might be warranted. So obviously we appreciate that. It looks like there aren't any other questions coming in, so just wanted to thank everyone again for their time this afternoon. I know we went a little bit over, so apologies for that, but it looks like a good amount of you still stuck around. So that's awesome to see. And thank you, Michelle, for taking some time to walk us through a great presentation.
No problem. My pleasure. Anytime.
Cool. Have a great day, everyone. Thanks again so much for your time.
All right. Thank you.
Bye-bye. Have a great afternoon.
All right. Bye.